All right, today what we're going to do is we're going to learn trig transformations. What we're going to do is we're going to take some functions and we're going to move them left, right, up, and down. We're going to start with what are the functions and what do they look like. And the types of functions we're going to talk about are linear, quadratic, radical, rational, absolute value, and cubic. Well, what are those basic functions? Those basic functions, a linear is y equals mx plus b. A quadratic is y equals x squared. And we have a number plus another number. I like putting question marks in there instead of anything else. A radical, that's our square root. Our rational, that looks like a fraction. An absolute value, that has the big bars. And a cubic is to the third power. So what are those shapes? The shapes of those functions, a linear is a straight line. It can be going up if your slope is positive. It'll go down if your slope is negative. A quadratic is a U-shape with your vertex at the bottom, or if it opens down, your vertex will be at the top. A square root or a radical is kind of a swoosh, as I call it, to the side. A rational makes what I think looks like a fraction with something above and below with your horizontal asymptote, and it makes boomerangs in opposite corners or opposite quadrants, in quadrant 1 and quadrant 3. Absolute value makes a V, and if you notice value, V with a value, it makes a V. A cubic makes what I call an S, or what I've heard students call as a waterfall. So what we're going to do is, how do these shapes move around a graph? How do we do those? How do we take the shapes and graph them? Well, what I like to think about is, how do we move this function? Now, the function has a house and outside the house. When you're inside the house, we don't want to listen to our parents. We always want to do the opposite of everything that we're told when we're in the house. But we get outside the house, we lay on the beach, we get outside the house, we do the same thing we always want to do. So, what do I talk about this? Well, when we have equations for a quadratic of maybe y equals x plus 5 squared plus 4, a radical y equals the square root of x plus 5 plus 4, a rational y equals 1 over x plus 5 plus 4, a cubic y equals x plus 5 cubed plus 4, and for an absolute value, y equals the absolute value of x plus 5 plus 4. Now, write all this out because it's really simple. We do the opposite when we're inside. So this 5, we're not going to go the right 5, we're going to do the opposite. We're going to go left 5, so that would be a negative 5. You notice it's right next to the x-axis goes right and left, so we're going to go left 5. Now, we're outside the house. We get to jump up and down. We get to do what we want on the outside. We do the same thing that it says. So we go up 5. And if we put this inside make our coordinates, then that makes the vertex of all of our points. So what is the difference in each one? The difference in each one is the shape, like we just wrote on the last slide. The shape, what shape happens at these points? Well, let's look and see what happens with that. Let's go on to the next slide and look at this. If we talk about these functions, what we just wrote out, inside the function, outside the function. Inside, remember, we do the opposite. So all of these is not going to be to the right 5, it's going to be to the left 5. So what we're going to do is go left 1, 2, 3, 4, 5, left 5. And we move from the origin. Then we're going to use our function and we're going to go up 4 because we do the same. So we're going to go up 1, 2, 3, 4, up 4. Well, where is that spot at now? Well, that spot's left 5, up 4, and that makes our vertex point. If we're talking about a quadratic, Let's just take that shape and put it right there. There we go. We got a sketch of our quadratic. What if I want the sketch of our rational? There we go. The square root function. What happens if it's a boomerang? What if it's rational? It's a fraction. Then we put our rational function there. Ooh, we don't want to move our point yet. We want to move the function. What if it's a cubic? Then we put the cubic function there and make that waterfall go through the point 5, -5, 4. What about the absolute value? Well, it gets placed there. So realistically, we move these functions the exact same. It's just what shape is drawn there. And that's all we have to do. So let's go back and look at each one of these individually. What happens if we take the parent function of y equals x squared? Now, y equals x squared is a parabola that starts at the origin and opens up. So what happens if I have it now, y equals the quantity x minus 3 squared plus 2? Well, remember, inside, we do the opposite. It's like being inside your house. We don't listen to everyone inside our house all the time. We want to do the opposite, so we're going to go right 3. And on the outside, we get to do what we want. Yay! So we do the same, so we're going to go up 2. So where are we going to go? We're going to go right 3, 1, 2, 3, and up 1, 2, and make our new point. And that is where we draw and sketch in our parabola now. So we moved right 3 and up 2. So this function here went right 1, 2, 3, and went up 1, 2 from what it originally went from. So now, let's look at another example. What happens if we take a square root, a radical function? Now, if we look at a radical, we have a -1 on the inside. That's going to go right 1 and up 6. So right 1 and up 1, 2, 3, 4, 5, 6. Remember, our parent function is a square root that sketches from the origin, goes whoosh to the right. So now we're just going to take this function, go right 1 and up 1, 2, 3, 4, 5, 6. And there we go. We just moved our function right 1 and up 6. Let's look at another example. What if we take a fraction, a radical function, or sorry, a rational function? Let me say that this is a rational function. Okay? So when we take this, that's opposite, so we're going to go left 2 and down 3. So 1, 2, so -2, and down to -1, -2, -3. Now here, remember, when we talk about a fraction, it makes a vertical asymptote, a horizontal asymptote, and it has boomerangs and opposite quadrants. So what we're going to do is we're going to take this entire function and move our asymptotes to the left 2 and down 3. So we have our asymptote that goes through here now. Now let's look at a cubic function. A cubic, remember, our shape here is the S, or the waterfall, and this point where it turns directions, point of inflection, that's the point that we're going to move right 8. Remember, opposite, you're inside, outside is the same, so we're going to go up 7. 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 6, 7. Make our point. And what shape is it? It's the waterfall. Excellent. Excellent. So, absolute value. What's the shape of an absolute value? Excellent. It is a V. Well, pretty sloppy V there. But it's a V. Remember, absolute value, V for value. So here we got to go left 2 and up 5. Left 2, up 1, 2, 3, 4, 5. That's going to be -2. Up 5. And remember, we got to make that V at that point. Now, let's recall what we're doing. Inside the function, the house. Remember, the house. Inside the house, inside the function, we do the opposite. Outside the function, you're outside the house, you do the same. So here, and remember, outside you're either going to go up if it's positive, down if it's negative. Excellent job. Awesome.